Welcome to the Explainer. Today, we're going to crack open the digital toolkit and take a look at the invisible architecture that makes all your favorite apps just work. We're talking about data structures.
All right, let's kick things off with a question that, believe it or not, gets right to the heart of how computers work. Think about a giant, messy pile of toys. Now think about your computer's memory. What could those two possibly have in common?
Well, it's pretty simple. Chaos. Trying to find that one specific Lego brick in a huge pile is a total nightmare, right? It's slow and inefficient, and it's the exact same problem for a computer trying to find one piece of data in a jumble. But if you stack your dinner plates neatly, you know exactly where to grab one. That organization, that's the key.
And that's exactly where computer science steps in with a really brilliant solution for tidying up all that digital chaos. The whole concept is called data structures, and honestly, it's the secret sauce behind why your apps run so smoothly. Now, you might read that definition and think, okay, it's just a way to store stuff. But here's the real key. A data structure isn't just about storage. It's a system. It's a set of rules for how you organize information so you can find it, change it, and work with it super efficiently. Okay, so with that idea of rules in our head, let's pull out the very first tool from our organizer's toolkit. We call this one the stack.
You know, the easiest way to get your head around a stack is to just think about everyday things, like a stack of plates at a buffet or one of those old CD spindles. There's one simple, really powerful rule. You can only ever add to the top, and you can only ever take from the top.
And this all comes down to one crucial governing rule. It's called the LIFO principle, which stands for last in, first out. The very last plate you put on that stack is guaranteed to be the first one you take off. This one simple idea defines everything a stack does. Now, because of that strict LIFO rule, you can really only do two things with a stack. When you add a new plate to the top, that's called a push. And when you take that top plate off, it's called a pop. That's it. Push and pop. Those are your only options. All right, so that's the stack. Now let's grab our next tool and see what happens when we change that one core rule. It creates a totally different, but just as useful, system. This one's called the queue. And the perfect analogy for a queue is something we've all done, waiting in line. I mean, whether you're at the grocery store or waiting to vote, the rule is universal, right? The first person to get in that line is the first person who gets served.
This, of course, leads to a different principle. It's called FIFO, which stands for first in, first out. So unlike the stack's last come, first served vibe, a queue is all about fairness. It processes things in the exact order they showed up.
And the way you interact with it totally reflects that rule. You always add a new person or a new piece of data to the rear of the line, but you always serve the person from the front. That's how you guarantee that the first one in is the first one out.
Now there's one interesting thing that both stacks and queues have in common, if they have a fixed size. They can run into two classic problems. Overflow, that's when you try to cram one more item into a container that's already full. And underflow is the opposite, when you try to take something out of a container that's already empty.
But what if you don't know how many plates you're going to have? Or what if that line of people could just keep growing forever? For situations like that, we need a much more flexible tool. We need the linked list. And this right here really gets to the heart of the difference. Some structures, like what we call arrays, are static. Their size is fixed from the start, kind of like a bookshelf that only has 10 slots. But linked lists, they're dynamic. They can grow and shrink whenever you need them to. They only use up memory when you actually add something new. So, how on earth does that work? Well, the scavenger hunt analogy is perfect. The items in a linked list don't all have to sit next to each other in the computer's memory. Instead, each item holds its own little piece of data, plus a clue, basically a pointer or a link that tells the computer exactly where to find the next item in the chain. So each one of those clues in our scavenger hunt has a special name. It's called a node, and every single node is made up of these two parts. You've got the data, which is the actual information you care about, and then you've got the link, which is just the address of where to find the next node. So, if you want to actually read what's in a linked list, you have to do this little dance called traversal. You start at the very first node, you read its data, and then you just follow its link to the next one. And you just keep hopping from node to node like that until you finally hit a link that points to null, which is just a fancy way of saying you've reached the end of the chain.
Okay,
Phew. So we've got the stack, the queue, and the linked list. 3 different tools in our toolkit. So the big question is, how do you know which one to use for the job?
Well, as you can see, it really just boils down to what you're trying to do. The whole last in, first out thing for a stack, it's perfect for the undo button in your software. The last thing you did is the first thing you undo. A queue's fair first in, first out system is ideal for managing print jobs. And the dynamic grow as you go nature of a linked list, perfect for something like a photo gallery on your phone, where you're always adding and deleting pictures.
So at the end of the day, what's the big takeaway here? Is that behind even the most complicated software you use, there are these surprisingly simple, really elegant ideas about organization. Stacks, queues, and linked lists are like the basic Lego bricks that build our entire digital world.
And now that you know these rules, these patterns, I promise you, you're going to start seeing them everywhere, from your web browser's back button to your music playlist. That's our look at the basics of data structures. Thanks for joining this explainer.